Welcome to today's Explainer. Today we're diving into something that's honestly a real game changer in the world of blockchain. We're going to explore exactly how scalable digital assets function when you completely strip away the usual bottlenecks. We'll be looking at the mechanics, the networks, and the absolute future of tokenization.
Okay, let's dive into this. How on earth do you scale digital assets on-chain without completely breaking the blockchain? It's pretty much the holy grail of this tech, right? How do you balance an incredibly high transaction volume with network stability? For years, blockchains have really struggled with this. They run into sky-high fees and crazy network congestion the minute digital assets or NFTs get popular. But the secret isn't to change the fundamentals of the blockchain itself. It's to look much closer at how we track and manage those assets.
So here's our roadmap for today. 1. The one-satoshi revolution. 2. Comparing SAT and STAS. 3. The problem with indexers. 4. Enter overlay networks. 5. Unlocking BSV21 tokens. And finally, 6. The Mandala network future. Let's get to it.
All right, part 1, the one-satoshi revolution.
So what exactly is a one-sat ordinal? Basically, it's a unique digital asset, think an NFT or a token, but the data is inscribed directly onto a single solitary satoshi. And since a satoshi is literally 100 millionth of a single Bitcoin, we are talking about the absolute smallest unit possible. Because it uses the UTXO, or Unspent Transaction Output model, these assets live entirely on-chain. There are no sketchy off-chain storage links that might just break tomorrow. The whole shebang is permanently bound to that tiny fraction of a coin. The life cycle here is actually incredibly straightforward. You mint the data, you lock it to that exact one satoshi, and you transfer it. Boom. What's really interesting about this slide is how the asset is tracked. Because there are no arbitrary dust limits stopping you from sending these microscopic amounts, the asset uses what's called origin-based indexing. Basically, ownership just follows the physical movement of that exact specific satoshi across the blockchain. You don't need some massive complex database to tell you who owns what. The movement of the coin itself is the undisputed record. It's brilliant.
Developer Luke Rohanaz really hit the nail on the head here. He says, BSV is unique because we can actually do transactions with a single satoshi. This allows for an entirely new class of micropayment applications, collectibles, and programmable assets. And honestly, getting rid of those dust limits, that's what opens the floodgates for true innovation. We are talking about shuffling around highly complex programmable digital assets for literally a fraction of a cent per transfer.
Moving right along to part 2, comparing one-sat and STKs.
Now, out there on the network, you've got a couple of different ways to create tokens. One-sat and STAS are two of the big ones, but they serve vastly different purposes. One-sat is super minimalist. It relies heavily on that origin-based indexing we just talked about, which makes it incredibly lightweight and perfect for hobbyists, artists, or just quick community mints. STAS, on the flip side, is your heavy-duty enterprise-level protocol. It's all about compliance, packing complex smart contracts right into the locking script to handle strict transfer restrictions. Neither one is better than the other. They just brilliantly tackle completely different needs within the same ecosystem.
Which brings us to part 3, the problem with indexers.
Developer David Case makes a great point here, saying it's not just about NFTs. We're creating a foundation for programmable digital assets that scale. But here's the catch. To build a foundation that scales globally, you really can't rely on clunky, centralized infrastructure just to read the blockchain. And, well, that introduces the major bottleneck we're facing right now with traditional indexers.
So the crucial point is that traditional generalized indexers use a method called global listening. Imagine forcing an exhausted librarian to scan every single word in every single book in a massive multi-terabyte library just to find the one single sentence you asked for. That's global listening. It requires absolutely massive storage, the server operating costs are through the roof, and worst of all, it creates a centralized single point of failure. If the indexer goes down, your app goes down. It just doesn't scale for the future. All right, part 4, enter overlay networks, the solution we've been waiting for.
When you compare that old, generalized method to overlay SPV networks, the difference is night and day. Instead of scanning the entire blockchain, in an overlay network, the sender just submits their transaction directly to the service that actually cares about it. Going back to our library analogy, overlays are like having the exact page you need delivered directly to your desk by the author themselves. It keeps storage super lean, operating costs plummet, and the whole system becomes modular and wildly efficient. The real magic making this happen is SPV, or a simplified payment verification. Overlays fundamentally shift the burden of proof. So instead of a scanner having to verify literally everything in the world, the sender is now the one who has to provide cryptographic proof that their specific transaction is valid. They use these specialized data structures, like BEEF, which stands for Background Evaluation Extended Format, to neatly package up just the transaction history needed to prove it's legit. This keeps the network beautifully decentralized and fault-tolerant.
This brilliantly illustrates how smooth an overlay node's workflow really is. It receives a transaction straight from a user, validates it instantly using that SPV proof, maintains the block headers, and then just shares it with its peers. That's it. It processes a transaction with total security without ever needing to look at or store the entire history of the blockchain.
Okay, Part 5, Unlocking BSV21 Tokens.
So, now that we understand the overlay infrastructure, let's talk about BSV21. This protocol is a massive leap forward for fungible tokens. See, older formats relied on global ticker symbols, which honestly caused a ton of naming collisions. BSV21 fixes that by using unique IDs instead. But the coolest part? It allows a single issuer to embed really complex, customized rules directly into the token using smart contracts. This absolutely opens the door for some serious real-world utility.
And why this matters for developers and users is just huge. You can build lock-to-mint contracts, where tokens are only released if certain conditions are met. Or check this out, POW20 tokens, where users actually solve localized desktop mining puzzles to earn their tokens. No more bots scooping up everything in a second. You could do direct membership club access, gamified community rewards, you name it. And because it's built on that one SAT baseline, developers can do all of this and reward users without anyone paying exorbitant gas fees. A total win-win.
Finally, Part 6, the Mandala Network Future.
Let's zoom out a bit and see how all this builds into the Mandala upgrade. This is a massive shift in network topology. We are finally moving away from that clunky old Web 2 client-server model and stepping into a peer-to-peer to miner, or P2P to M architecture. It's essentially a brand new internet structure where the core nodes have one job and one job only, building blocks. Everything else, push right out to the edges of the network.
1.1 million. That is 1.1 million transactions per second. Let that sink in for a second. That's the tested capability of Terranode, the new core software powering the absolute center of this Mandala network. When you free up the core to just process transactions and nothing else, the throughput becomes virtually unbounded. So here is the ultimate takeaway. This extreme division of labor is exactly what changes the game. Terranode handles the raw volume in the center. Meanwhile, out of the edges, specialized overlay services and SPV wallets handle all the data storage, token indexing, and user interactions. This perfect synergy is what makes enterprise-scale tokenization globally scalable and incredibly cheap.
We've seen how a single satoshi can hold a unique, unchangeable asset. We've explored how overlays completely bypass those clunky indexers of the past, and how Terranode brings the heavy firepower. So with unbounded scaling, practically zero costs, and true peer-to-peer overlay networks at your fingertips, what will you build on this new internet? Thanks so much for joining this explainer, and stay curious.